Alright, this is just a quick video on inequalities, just a couple of the pitfalls that people fall into, so I'm just going to cover them real quickly. First of all, you need to know what they're called, not just that it eats the bigger one. This is called a greater than. It's graphed with an open circle pointing to the right. This is a less than, open circle pointing to the left, because we're running all the numbers less than it, all the numbers greater than it. The only thing that changes is when you go to a greater than or equal to, that line on the bottom means greater than or equal to. That's a greater than. Filling it in means greater than or equal to. So the same thing here. That's a less than. That's a less than or equal to. Alright, so I'm just going to do two problems reminding you of some things that people struggle with. Remember, we're going to have a range of answers for each one of these. When I see this one, it says, when I read it, 38 is less than 7m minus 4. One thing that a lot of people struggle with is when the variable is on the right hand side rather than the left hand side. In an equation, we were always able just to flip it. So if you had f equals 7, that's the same as 7 equals f. Because in equality stays equal. Doesn't matter which side of the scale you're on. Or you can put the f on the left or the right, and the 7 on the left or the right. Doesn't matter as long as it stays equal. But on an inequality, if I flip this, which I'm going to do just to show you, flip the 38 to the right and the 7m minus 4 to the left. Remember, this thing needs to eat the bigger thing. You learned that in grade school. I kind of wish you wouldn't have, but you did. That means this thing was the bigger thing. It still has to be the bigger thing. So guess what? If you flip an inequality left to right, you have to flip the sign as well. So no longer is it a less than, it's a greater than. Personally, I like the variables on the left. That way this will actually match what you graph. Okay? So when I do this, of course, I solve it exactly like an algebraic equation. I would say they did this, then this. So let me add 4, divide by 7, divide by 7. And what you come up with is m is greater than 6. Let me graph that. At 6, it's not filled in because it's not equal to. M has to be greater than 6. So some people, well, let's just start at 7. No, because there are infinitely many numbers between 6 and 7. Anything bigger than 6 works. Alright, so let's try another one. Negative 5g plus 3 is greater than or equal to negative 27. The variable is on the left, which is what I like. But this one has a special thing that we need to talk about. That negative right there. That negative doesn't matter, but that negative is going to matter in just a moment, and I'll explain why. So, once again, they did this, so let me undo this. Subtract 3 from both sides. Those cancel out. Of course, get negative 30. Everything seems to be going along the same. But this is the other special occasion, another thing to remember for inequalities, is when you multiply or divide by a negative. And I'm getting ready to divide by a negative right here. When you multiply or divide by a negative, you need to flip the sign. It was a greater than or equal sign. Now it's going to be a less than or equal sign. Once again, they cancel out. G is less than or equal to positive 6. So, once again, almost the exact same one we had up there, only one difference. At 6, but you have to fill it in because of that inequality, or that equal to as well. So, two times when you might need to flip that symbol. If you want the variable on the other side, you're going to have to flip the symbol. If you multiply or divide by a negative, it has nothing to do with adding and subtracting, only when you multiply or divide by a negative. Because think about this. If I would have gone back to this one, and I would have only divided by 5, if I would have only divided by 5, I would have got the opposite of g is greater than or equal to negative 6. When I divide by that negative 1, first of all, I don't want to know what the opposite of g is. I want to know what g is. So when I get rid of that negative, I'm actually switching the negative identity over to the other side again, which makes that a positive, makes that a positive, and then that thing has to switch back to that less than or equal to. Okay?